many ways can 6 boys and 6 girls be seated alternatively in a row? Okay, so here, right, we need to consider cases. Okay, now case number 1, right, because if we alternate 6 boys, 6 girls, so for example, this, let's say we do 1, 2, 3, 4. Let's say if we don't even consider 6 boys, we solve a smaller, let's just consider 3 boys and 3 girls first, right? So if I were to alternate them, we consider that it can be boy, girl, boy, girl, boy, girl, right? It can also be girl, boy, girl, boy, girl, boy, right? So these are the 2 possibilities, right? And then within this arrangement itself, let's say if I just consider within this arrangement itself, how many ways can I arrange the boys? So let's say if I were to consider maybe just the girls first, right? Girl 1, girl 2, girl 3. Remember that humans are distinct, so these are counted as n distinct items, alright? Alternatively, you can see that if I were to arrange these 3, there are a total of 3 factorial ways. These 3, another 3 factorial ways. Alright? So, okay, we're only talking about 3 boys, 3 boys and 3 girls. So, if I were to arrange 6 boys and 6 girls, 2, 3, 4, 5, 6, 8, 9, 10. Okay? You can see that, for example, if I put boy, 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 alternatively, right? A total of 6 boys, right? Okay, the number of ways which I can arrange them, right? 6 ways to go into the first one, 5 ways, 4 ways, 3 ways, 2 ways, 1 way to the last one. So for the boys, right, it's 6 factorial ways. For the girls, you see, I also have 6 slots, so another 6 factorial ways. 6 factorial, 6 factorial. I also need to consider that it could be, instead of boys starting first, could be girls starting first, right? So for this combination, this is boy starting first, but I can also have girl starting first. So girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, boy. Girls can start first. So there are a total of 2 such arrangements. Okay, so if you see the yellow, those in yellow, right? I can have 2 arrangements. So after that, multiply by the number of ways the boys can arrange, multiply by the number of ways the girls can arrange. So for part A, my answer is just 2 times 6 factorial times 6 factorial, which is 1036800 ways. Okay, how about for part B? Okay, part B is slightly more challenging. Okay, so how we do this is, number 1, we can fix the boys first. Okay, so we want to arrange the boys at a round table. How we go about doing this is we can go, maybe we just first fix boy 1, okay, boy 2, boy 3, boy 4, boy 5, and boy 6. Right, so these 6 boys, if I arrange them in a circle first, right, how many ways can we do it? Okay, so very quickly, you know the answer is just 5 factorial. Alright, 5 factorial. Now consider that we are going to slot in the girl. So this is a slot for a girl. 1, 2, 3, 4, 5, 6. So how many ways now can we slot the girl? So you think, actually now, right, we're in the second stage of slotting. Arranging these girls would no longer be different. It will no longer be the same as arranging the table, because, for example, let's say if you look at this seat is very unique. Okay, can you see that for this girl sitting here, B1 is on the left, B2 is on the right, and you can see that no other seat, right, in this circle gives you this arrangement. So this is unique, right? So whether we go clockwise or anti-clockwise, right, this seat is actually unique. How about this? It's also unique between B2 and B3, between B3 and B4. And if I sit here, B4 is on the right, B5 is on my left. If I sit here, B5 on my right, B6 on my left. So the arrangement is unique. So if you think about it, right, how many ways can I arrange the girls, right? It's actually 6 factorial. Alright, it's not 5 factorial. So most people think it's 5 factorial. 5 factorial can if the boys are not there. But if the boys are there, you notice that the boys sort of in a way number the seats. They actually decide the seat. Okay, so it's actually 5 factorial times 6 factorial, and your answer turns out to be, for part B, the answer turns out to be 86400 ways. Okay, And for part A, recall it's just a 2 times 6 factorial times 6 factorial, which is 1036800 ways.